Alright, we're going to take a look now in example 9 at a system of equations in which both equations are parabolas. Alright, so we've got 6x squared minus x minus y equals negative 1, and 4x squared minus 4x minus y equals negative 6. Right, they both have square terms, they are both parabolas. One of the nice things about parabolas is we don't have to use substitution for parabolas. We also can use elimination if that is what you like. Both methods of solving systems works for parabolas when you have two parabolas. If you have a line and a parabola, you pretty much have to do substitution. But if you have two parabolas, you have the option of solving using substitution or using elimination. And so I'm going to just solve it using elimination. Alright, now the variable that we're going to eliminate is the y variable. So I'm going to take my first equation and multiply it by negative 1. So I get negative 6x squared plus x plus y plus 1. My second equation is 4x squared minus 4x minus y equals negative 6. And in the method of elimination, we add the two equations vertically to get negative 2x squared minus 3x, positive y and negative y eliminate, and we get negative 5. Alright, we're left with a quadratic equation, so we have to make it equal to 0. 2x squared plus 3x minus 5, which I think we can factor. 2x and x, and let's see, plus 5 and minus 1. Right, if you notice that's positive 5x and negative 2x, which gives us the positive 3. And so we get two possible solutions. X equals negative 5 over 2. And the second factor gives us a solution of x equals 1. Right, once we have done that, we need to get our y values by substitution. I'm going to use the second equation here. Oops. Right. So we get x equals negative 5 halves. We have x equals 1. I'm going to use the second equation, 4x squared minus 4x minus y equals negative 6. So we got 4 times negative 5 over 2 squared minus 4 times negative 5 over 2 minus y equals negative 6. This gives us 25 plus 10 minus y equals negative 6. So negative y is equal to negative 41, or y is just 41. Right, now to figure out our second point of intersection, we've got 4 times 1 squared minus 4 times 1 minus y equals negative 6. Which gives us 4 minus y equals negative 6. 4 minus 4 is 0, so we get negative y equals negative 6, which gives us y is equal to 6. So we have two solutions here. So the parabolas cross at 2 points, negative 5 halves and 41, and 1 and 6. All right, B says verify your solution. All right, so let's take a look. All right, we've run out of room, it appears, but to verify our solution, we would substitute in x equals 1. And so we get 6 times 1 squared would be 6, minus 1 is 5, and y is 6, so we'd have 5 minus 6 is equal to negative 1. All right, so we know for sure that that works in one of the equations. Let's check it in the second equation. We got 4 times 1 squared is 4, minus 4 is 0, minus 6. All right, so that point works in both equations. You can check the second point similarly. It's a little bit more work, but I think you'll find that it works out just as well. So, when you have two parabolas and you want to solve them, you can use either method, substitution or elimination. I illustrated this method using elimination. All right, we got rid of the y variables. We came up with a quadratic equation that we could factor, and we got two solutions. All right, and you should always remember to check your solutions. All right, let's take a look at our final example 10. It says Terry makes a good hit, and the baseball travels on a path modeled by h equals negative 0.1 x squared plus 2x. Ruth is in the outfield directly in line with the path of the ball. She runs toward the ball and jumps to try and catch it. Her jump is modeled by the equation h equals negative x squared plus 39x plus 3 or minus 378. In both equations, x is the horizontal distance in meters from home plate, and h is the height of the ball above the ground in meters. Solve the system algebraically, round your answer to the nearest hundredth, and B, explain the meaning of the point of intersection. What assumptions are you making? All right. We've got the system of equation h equals negative 0.1 x squared plus 2x, and h is equal to negative x squared plus 39x minus 378. I'm going to use a substitution here to solve this. Negative 0.1 x squared plus 2x equals negative x squared plus 39x minus 378. Alright, this is a quadratic equation, so we need to make it equal to 0. Adding x squared to both sides, we get 0.9x squared. Subtracting 39x from each side, we get negative 37x. And adding 378, 378 equals 0. Alright, it doesn't look like there's going to be much of a chance of us solving this by factoring, so we're going to have to use the quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we get x equals negative 37 plus or minus the square root of negative 37 squared minus 4 times 0.9 times 378 divided by 2 times 0.9. So we get x equals 37 plus or minus the square root of 8.2 divided by 1.8. Alright, this gives us x equals 37 plus or minus 2.863564 divided by 1.8, which gives me two values for x. 37 plus 2.86 divided by 1.8 is 22.15, or 37 subtract 2.86 divided by 1.8 gives me 17.07. So we've got two possible places to where these curves will intersect. I'm going to use the we're going to use the first equation, h equals negative 0.1 x squared plus 2x, and so we've got h is equal to negative 0.1 times 22.15 squared plus 2 times 22.15, which gives us h equals negative 4.76. The other one, we've got h equals negative 0.1 17.07 squared plus 2 times 17.0, which gives us h is equal to 5.00. Alright, so this is probably going to be rejected because it doesn't make sense to catch the ball when it has a negative height. That means it's hit the ground already. This, catching the ball when the height is 5, makes the most sense. Now, realistically, 5 meters is an awfully long jump, so that might not be 100% realistic, but this is the only answer that makes sense. Alright, so to recap, if you have parabola systems, you can use substitution or elimination. In the first example, we used elimination to find our points of intersection. In the second example, we used substitution. Right? My preference is to learn how to use substitution because substitution has far more application than elimination. Alright, in support of this, I'd like you to work on the assignment from pages 451 to 456, numbers 1 to 5 odd parts, 7, 9, 12, and 20.